In Packet Tracer 1155, we are going to subnet a customer network into multiple subnets based on the number of host computers required in each subnet. We will fill in the table with all of the addressing information, configure the host PCs, switches, and router interfaces, and then use the ping command to test for network connectivity. In part one, we are to create a subnetting scheme to meet the required number of subnets and the required number of host addresses. We have been given a network address of 192.168.0. This is a /24, and we are to use that to meet the following requirements. The LAN A network is going to need at least 50 hosts. The LAN B LAN is going to need at least 40 host IP addresses. The customer wants at least 2 more subnets that are not in use for future growth. We will be using the same length of subnet masks for all of these subnets. We're not going to be doing variable length subnet masking. First, we have to answer some questions. How many host addresses are needed in the largest required subnet? So the largest number of hosts needed are 50 hosts in LAN A, and I'm just going to grab the document here. The next question is, what the minimum number of not host addresses, but subnets? So we've been asked for 1 subnet for LAN A, 1 for LAN B, and 2 more for future expansion. So that comes to a total of 4 subnets that will be required to subnet out. The network we are asked to subnet from is 192.168.0.0/24. What is the /24 subnet mask in binary? The /24 means that the first 24 bits are ones, so the correct mask would be 8 ones in the first 3 octets and all zeros in the 4th octet. In the network mask, what do the ones represent and what do the zeros represent? The ones represent the portion of the address that is the network portion. The zeros represent the portion that is the host portion. In F, to subnet a network, borrow bits from the host portion and change those into subnet bits. The number borrowed defines the number of subnets it will yield. In the next section, we're going to be given possible subnet masks and asked to figure out how many subnets and how many hosts each would give us. Remember that the number of host bits to the power of 2 defines the number of hosts per subnet. If we have 1 bit borrowed from the host portion, that's going to determine how many subnets, because we would take 2 to that power. 2 to the first power is 2. So that's how many subnets it would give us to borrow 1 bit from the host bits. If we just took the network as a /24, that would be 8 host bits, which would be 2 to the 8 is 256 total hosts, minus 2 would be 254 if we didn't do any subnetting. If there's no requirement for that many hosts, IP4 address space is scarce. So that's why we are wanting to subnet down, not only make our broadcast domains as small as possible, but also to make our address space go as far as possible. We don't need 254 usable host addresses. We have a requirement that we're going to choose how we want to subnet this. Starting with the /25, where we borrow 1 bit, what would be the dotted decimal subnet mask equivalent? So we would have a /24 plus, in that last octet, we're taking the very first bit here, which is the most significant bit. This position is the 128 position. So that's going to be a 128 in the 4th octet. How many subnets will that give us? 2 to the first power is 2 subnets. And how many hosts are going to be in each of those 2 subnets? To calculate that, we look at what's remaining, 7 host bits. So we take 2 to the 7th power, which gives us 128, But we have to subtract 2 because the first goes to the network and the highest goes to the broadcast address. So that leaves us 126 usable hosts. So the lower the number of subnets, the higher the number of hosts you're going to get. We are looking at 126 usable hosts. At /26 in the next scenario, 255.255.255. Then we look at, this is 128, this position is 64. You add those together and you get 192 in the fourth octet there. How many subnets would that give us? Borrowing 2 bits from the hosts is going to give us 2 to the second power is 4 subnets. How many hosts? We have 6 host bits left, so we take 2 to the 6th is 64, subtract 2 to get 62. What about if we were to make a /27 as our prefix length or subnet mask? That fourth octet, this is the 32 position, so we're adding that to the 192 that we already had, and that gives us 224. That's going to give us 2 to the third power because we're borrowing 3 bits, so that's going to be 8 subnets. And each of those 8 would have 2 to the 5th power minus 2 is 30 hosts. The /28 is going to use the 16 position bit, so we would add that to our 224 is 240 is our mask. And that will give us 2 to the 4th power is 16 subnets. And we have 4 host bits, so 2 to the 4th power we know is 16, but we subtract 2 to get 14. If we use a /29, our mask, now we've got the 8 position bit set as a network bit, so that's going to be 248 in that last octet. We have 5 borrowed host bits to make them network bits, so 2 to the 5th power is 32 subnets. So the higher the number of subnets, the fewer hosts per subnet. So we have 3 host bits left. 2 to the 3rd power is 8 minus 2 is 6 hosts per subnet. That'd be pretty small. And finally, the /30, the subnet mask. Again, we are taking the 4 position bit, so we're adding 4 to the previous mask. That gives us 252. 2 to the 6th power gives us 64 subnets, but each one has only 2 usable host addresses. Considering your answers, which subnet masks meet the required number of minimum host addresses? So we have one LAN that needs 50 and one LAN that needs 40. Which one of these would give us at least 40 hosts? That would be anything above the /26. So the /25 and the /26 both would provide enough hosts. And how many of those masks meets the minimum number of subnets? Well, we only need 4, so pretty much all of them except for the /25 are going to meet that requirement of at least 4 subnets. So now that we figured all that out, what subnet mask should we use? Which one meets both the required minimum number of hosts and the minimum number of subnets required? At least 40 hosts and at least 4 subnets. So the best one that would meet that requirement would be the /26, right? It'll give us 4 subnets and 62 hosts per subnet. So the /26 is the subnet mask we're going to need to use here. And the mask for that would be 255.255.255, 192 in the 4th octet. Now that we've determined which subnet mask meets all of our network requirements, we're going to break it down into the subnets for each LAN, but instead of that /24, it's our chosen subnet mask, the /26. The prefix is going to be the same because we're using the /26 for all of the subnets. So that will go in the prefix column, and the subnet mask 255.255.255.192. That is what the subnet mask is for a /26. We know that the first subnet is going to be 192.168.0.0. And I'm going to add some notes in here to make it easier to address the interfaces and things later. I want to put down what are my usable host addresses. The first .0 is reserved for the network, so my first usable host address is going to be .1. My last usable host address will be the one before the broadcast address. So one nice thing to know is it's something called the magic number that you add to the network address to get the next network address. That's going to be the number of hosts possible. In the /26, there are 64 possible hosts, 2 to the 6th power. Before we subtract those two reserved addresses, that 64 is what you can call your magic number that you can use when you're adding to get your next subnet. So the .64 then would be the next subnet address, 0 plus 64, which means that your broadcast address is going to be .63 for this subnet, and the last usable host address is going to be .62. And making notes like this is really helpful. So for my next subnet, I know that's going to be 192.168.0.64 network. And on that network, the first usable host will be .65. Again, we're going to be adding a 64 to get the next network address. The broadcast address of this network is going to be .127, and the last usable host will be .126. So our third subnet, 192.168.0.64 plus 64 is 128. And our fourth subnet is going to be 128 plus 64, 192. Usable hosts will be .129 through .190 with a broadcast address of .191. And in that last subnet, our usable hosts will start with 193, because 192 is the network address. And 192 plus 64 would then give us 256. So the broadcast address, 255, and our last usable host address would be .254. So hopefully this is starting to make sense. Now that we have that mapped out, we're going to assign the first subnet to LAN A. So I'm just going to add, you don't have to do this, I just find it's really helpful. The second subnet is going to go to LAN B, and the other two subnets are going to be for future use. So our first host address is going to be for the customer router interface that's connected to the LAN A switch. And we can fill in our IP addressing table. So our first host address for LAN A, 192.168.0.1, is going to go on the interface on the customer router that's facing LAN A. So this interface right here, which is gig 00. And we know our subnet mask by now. We're not going to be configuring a default gateway for the customer router. The second host address is going to go on the LAN A switch, and that's going to be .2. LAN A switch, VLAN 1, same mask, and the default gateway is going to be the customer router IP address that's in that subnet. This is also going to be the default gateway for PCA. So I'm going to go ahead and fill that in. That is supposed to be the subnet mask. They're all going to be using that same subnet mask. The IP address for PCA is going to be the last possible host address in that range, which I can go back in my notes. I can just grab that. It's going to be the .62. And now that takes us to For LAN B, we're going to use the first host address for the router interface, the second host address for the switch, and the last host address for PCB. Okay, so in that second subnet, the network that begins with .64, the first host address is .65, and that goes on the router on the interface facing that LAN, and that will be the default gateway as well for both the switch and the PC. The second usable IP address then would be .66, which is what goes on the switch virtual LAN interface. And the last usable host address is the .126. And that's going to go on PCB. And that takes care of the addressing table. Now we can start configuring. So grab the customer router, go to the command line interface, enable for privileged exec, configuration mode, conf T for short. First, set the enable secret password to class123. Enable secret because we're going to encrypt that, and then the actual password is class123 with a capital C. Make sure that it looks just like that so your grading works. Next, set the console login password to Cisco123, and that dot there, that's the period at the end of the sentence. The password won't have a dot in it. So we go line console 0 password uppercase C ISCO123. Remember, the command that always goes hand in hand with password is login for password checking. Next, host name. You can do the host name command from line configuration mode. And customer router, uppercase C, uppercase R is what the grading will check for. The prompt has changed to reflect the new host name. Now we're going to put our IP addresses on our interfaces, looking back at our table G00. So if I say do show IP interface brief, we're going to have to also administratively enable them with the no shut command because they are disabled. Interface G0/0, IP address 192.168.0.1, followed by the subnet mask, which is the /26.192 there. And of course, no shut to enable. See a message that it's coming up. Interface G0/1. IP address is going to be 0.65 with the same network mask. And no shut. Let me fix my document here and get that mask filled in. There we go. Show IP interface brief now shows up and addressed. Then save the running configuration. Copy run star for short. And that looks like all we need to do on the customer router. Now we're going to go over to the switches because they need IP addresses too so that they can be managed. LAN A switch, command line interface, enable, conf T. If I do show IP interface brief, VLAN 1 is currently unaddressed and administratively disabled, but not for long. LAN A switch has the address, sorry about that, that one is supposed to be .2, which is the second usable IP address in that subnet. Select an interface, VLAN 1. IP address is, just paste that in, and my mask, and remember to do the no shut. We also have to tell this switch who is its default gateway so that it can communicate or be communicated with other networks, and that is going to be IP default gateway, and that will be the .1 interface on the router there. And at this point, I like to make sure I can ping the default gateway. So like if I show my ARP table right now, I've got an entry here for the switch's IP address as well as its MAC address. And if I ping the default gateway, make sure everything's working and I can reach the router. That first ping failed because it was doing the ARP request because it didn't know the MAC address. So now if you check the ARP table, you see there's the default gateway router interface address and its corresponding MAC address. So the next time that it goes to ping, it won't have to ARP because it already has that information in the table. The other switch now will need to be address, which is the LAN B switch. Enable conf t interface VLAN 1. IP address for VLAN 1 on the LAN B switch is going to be .66. The second usable address in that .64 network. And no shut. And its default gateway, IP default gateway 192.168.0.65. And I just want to make sure it can ping its default gateway. Yes. Now the PCs have to be configured with their information. So PCA and LAN A, that one got the last usable host address in the subnet. So we go to desktop IP configuration 192.168.0.62. Well, this is going to be a static address. The subnet mask will auto-populate, but it's going to be a classful mask. We've got to change that because we're subnetting. That's going to be .192 there. And make sure to put in the default gateway information, which is going to be 0.1. The customer router is the default gateway. And over on PCB, .126. Again, fix that default mask there. And its default gateway is G01 on customer router, which is .65. Okay. And finally, use the ping command to test network connectivity. PCA should be able to communicate with its default gateway. PCB should be able to ping its gateway, and the two then should be able to ping each other. Get our addresses here where we can see them. So PCA is going to want to ping .1 as its default gateway. And that is successful. PCB is going to want to be able to ping its default gateway. And if you forget, you can do an IP config, and that'll tell you who the default gateway is. And that is successful. So if everything is working end to end, then these two PCs will be able to ping each other. So PCB ping PCA. And that is also successful. So everything is looking good. These are all going to be yeses. If they're not yeses, go back and check all of your IP and subnet mask configurations, default gateways. Also, you should see 100% completion. If not, hit the check results button and look at the assessment items and look for red X's. Once you're done with everything, make sure you save it. Thank you.